Hi, this is Kevin Trainer, and I'd like to welcome you to my lecture on Chapter 11 of the Murach MySQL second edition textbook. Chapter 11 is entitled How to Create Databases, Tables, and Indexes. So the learning objectives for the chapter I'm going to leave for you to read on your own. And we're going to jump right into the statements, okay? And um, the SQL statements are divided into the DML, the data management language, which we've already learned a lot of, and the DDL, the data definition language, which we're starting to learn right here. And the first statement that we're learning about is create database. And as you can see in the first line here, we have the ability to use the option if not exists. So if we were trying to create the database AP, like the practice one we have, the accounts payable database, we could just say create database AP, or we could say create database if not exists AP. And certainly, if you're trying to recreate everything from scratch, it's always kind of safe to use this if not exists option because you don't know if there's one previously defined. A lot of times you want to run your script in order to you know, reset the database. So the if not exist option is a good option for that purpose. And the opposite of creating a database is dropping the database. Okay? So we can either say drop database AP, or we can say drop database if exists AP. And again, the if exists option allows you to check if there's already a database there and get rid of it before you create your new database. And certainly, if you want to create a pretty general script to reset the database, um, this is a useful option again here. The use statement we've been using throughout the course in my version of the course because I don't want us to rely on the feature in MySQL Workbench where you have to double click on the database in order to pick the database you want to run your query against. I want to be explicit. So we've been using this all along. The only thing I would do differently than this use AP is I would put a semicolon after use AP because it's probably going to be part of a script. So we're going to want to use the semicolons to separate the statements. How do we create a table? Well, of course, with the create table statement. And there's a syntax diagram at the top. And rather than trying to wade through that gibberish, I just want to go to the examples. But we say create a table name. And then we provide lots of detail on the columns and potentially the attributes for the columns and the data types for the column and all that kind of stuff. The column attributes that we're talking about are properties like not null, unique, default, auto increment. Okay? So here on slide 8 is a statement that creates a table with column attributes. Okay, so we create table vendors, and then you see that the details of the table are in a set of parens. Okay, and the typographic treatment that we get here, where they put the left paren on its own line and the right paren on its own line, you don't absolutely have to do that, but I think it's a good practice. So I kind of like the way they've done that here. So then we say vendor ID, that's the name of the column. So we say create table vendors, parens, vendor ID, that's the name of the column, int, that's the data type for the column. And then we've got 3 column attributes that we want to apply: not null, unique, auto increment. And it's only after we have named the column, specified the data type, and specified 3 attributes, all of them only separated by spaces, that we have a comma that separates the definition of one column from the definition of the next. Okay, so it's very generous in allowing us to separate things with just white space, although the columns have to be separated by commas. Here's another statement that creates a table with column attributes. So we're creating table invoices, and the column names are invoice ID, vendor ID, invoice number, invoice date, invoice total, payment total. And the data types are int, varchar 50, date, decimal 92, decimal 92. And the attributes that we have are, for the first column, the attributes for invoice ID are not null, unique, which is nice, but I just want to point out that we haven't picked up primary key here. If you look through all of the attributes, there is an attribute way to say that a particular column is the primary key, and we haven't done it. Okay, so for these, we're using not null and unique for the first field, not null for a couple of others. It default 0 for the last one. We are separating the definitions of the columns by commas. Okay, now here on slide number 10, we actually make a distinction that I did make in my comment on the last of the slides. The things that we've been specifying before are technically called column attributes. So let's just back up. So not null, unique, default, all those things are column attributes. When we come to slide number 10, you'll see that we can use the primary key. It is a column level constraint. So it's kind of like an attribute, but it's not called the same thing. So if you see what we have here, create table vendors, vendor ID, the data type is int, it says primary key, auto increment. So primary key is a column level constraint, auto increment is an attribute. Okay? So that's how we can very easily identify a primary key when the primary key is only has one contributing column. And that's pretty typical, but we do see situations where primary keys for tables are made up of more than one column. In that case, we're going to have to use another syntax. Okay, but this one where we do it at the column level out there with the attributes, this is a pretty easy way to do it. Okay, now on the next slide, slide number 11 here, we see a similar thing done, but we haven't declared primary key at the column level. We've waited until after we declared both of our columns, vendor ID and vendor name. We've left off that primary key constraint on vendor ID. That allows us to specify a constraint at the table level. You specify table level constraints after you've defined all your columns. So we've defined vendor ID, vendor name, and then after the comma that closes the vendor name column declaration, we say constraint vendors PK, that's the constraint name, primary key, and then in parens the columns that contribute to it. Now here we just have a single column name. If we had multiple columns that contributed to the primary key, we would have column 1, comma, column 2, comma, column 3. And then we have a constraint vendor name UQ for unique. It's a unique constraint on vendor names. So these constraints that we have, some of these things can be specified at the column level, and some of these, and also in the alternative, they can be specified at the table level, like we see here. Okay, here on this next slide, we have an example of a two-column primary key constraint. So this kind of primary key, you can only set up at the table level. Okay. So we say at the bottom, the constraint is called line items PK, line items primary key, and then in parens invoice ID, comma, invoice sequence. So that's how we get that one done. Here's we're going to do the same kind of set of things for foreign keys. So if we have a foreign key, which is a column in our table that points to the primary key of another table, and if it just involves a single column, which is common, then we can define them at the column level just like we did for the primary key. So here on slide 13, we can see that the second column vendor ID of type int is a foreign key. And how do we know that? Well, because it uses the language of a foreign key declaration. It says it references vendors, that's the name of the table, and then in parentheses, vendor ID, the name of the column. Okay? So that's how you would do it at a column level. You can also do it at a table level. So here on slide 14, we see that we're doing this at a table level. Okay, so after we declare the last of our columns, we have a comma, and then we say constraint invoices FK vendors, which says this is the foreign key that relates the invoices table to the vendors table. Foreign key, then we have vendor ID, references vendors, vendor ID. So we need to say which column in our table participates. So foreign key in parentheses vendor ID, that is the column in our table that participates in the relationship. References, then the other table, vendor, then in parens, the name of the field in the other table. It's a good practice to have these things have the same name unless there's some kind of special consideration. Like if you have a foreign key that points into your own table, it doesn't work to use the same name. Or if you've got, say, two foreign keys that point to different rows in another table, typically you prefix the field name. Something like uh, billing address ID, shipping address ID. Okay? Okay, so once we set up foreign keys, these are going to restrict our ability to do inserts on the table and do deletes on the table. So here is a situation where, having already defined these things, we insert into invoices values 1, 1, and then in quotes a 1, so that's a string 1. And we get an error code, 1452, cannot add or update a child row. A foreign key constraint fails on invoices. The constraint invoices foreign key vendors. Foreign key vendor ID references vendor's vendor ID. Well, the problem is that that vendor is not there. Okay? So in order to preserve referential integrity, if we try to do an insert and we're pointing to a row that's not there, then we're going to get an error. Now, we do have the same, when I back up a second here, we're going to have the same issue. Let's say that we had a row in the vendors table, so we were able to do the insert. We're going to have the same issue if we go to the vendors table and we try to do a delete, and we have an invoice that points to that row in the vendors table. It's going to say, well, you can't delete that vendor from the vendors table because it's got an invoice that's pointing to it. Now, you can actually set up your definition for constraints, and you can say that if in fact you get a delete on the other table, to delete the row in this table that's associated with it, and that's called delete cascade. Okay, so when we declare the foreign key, one of the options is we can go ahead and say on delete cascade, which says if you went to delete the vendor, instead of saying, oh, no, you can't delete the vendor, it has invoices, not only would it delete the vendor, it would also delete the invoices. Okay, so I would say that in the case of invoices, this is a bad idea. Okay, this is a classic situation though. Let's say we had a database in which we were keeping shopping cart information for our e-commerce app. And let's say that we had a relationship between a shopping cart and the items in the shopping cart. Okay, well, perhaps we would set up the foreign key in some way, like the using the options that we see here, that when you delete the shopping cart, you delete all the items that are in the shopping cart. Okay, because once the shopping cart's gone, who cares what had been in the shopping cart? Okay, so that's a more useful example of how you might use this kind of feature. So some terms to know. Constraint, things like the primary key constraint, things like the foreign key constraint, things like the unique constraint. Okay. Column level constraint, one that we set up as we declare the column, we declare it in line. Table level constraint, still part of the definition that we have of the table, still when we're declaring the table, it's still part of that. It's just that when we close the comma on our last column, then we can add constraints. Not null constraint. That says that you don't want the column to have null values. Unique constraint. It has to be unique. Primary key constraints identify the primary key, and they typically imply not null and unique. Foreign key constraints identify, set up a foreign key relationship. Now, once you have defined your table, there's really two use cases in which you're going to want to change your table. Let's think about that. Use case one, we're still designing our tables. We don't have them right yet, okay? And we remember a column that we forgot. We remember some kind of a constraint that we forgot, and we just want to add it, okay? So we can use this alter table statement in order to add a column, drop a column, modify a column. We don't particularly have to worry about the data that's in the database because we don't have any data in the database yet. We're still defining it. Now, compare that with what I would call use case two is we have an application. It's been running for a while. We've got plenty of data in the database. We have plenty of rows in all of our tables. And then we decide that we want to change some aspect of the database. We want to add a column. We want to drop a column. We want to modify a column. Well, that's a little more complicated, right? Because that might actually compromise some data that is already in the database, okay? So we'll talk about that situation when we get to it. So here's a statement that adds a new column, alter table vendors, add last transaction date, which has the type date, okay? And one that drops a column, alter table vendors, drop column last transaction date, okay? Either of those two will work. Now, I just want to point out that if you're using MySQL Workbench in order to do a lot of this DDL stuff, okay, and you are, say, adding columns using the graphical user interface of MySQL Workbench, when you finally say that you want to apply the changes, you will actually go to a point where you'll actually see the alter table DDL statement that's been generated, and then you can either apply or cancel. So even though you might be using the graphical user interface in order to make adjustments in your schema, um, these kinds of statements are going to be sent to the server on your behalf by MySQL Workbench. And it's kind of interesting to see them. Here's a statement that changes the length of a column. So we're going to alter table vendors, modify vendor name var 100, not null, unique. Okay? And here's one that changes the type of a column. Modify vendor name char 100, not null, unique. Because those two can both handle 100 characters long, in the varchar sense, they're not going to be padded if they're shorter, and in the char, and the one with the char, they will be padded on the right if they're shorter strings. But because those two are the same length, and we're assuming that our original length is 100 or fewer characters, then we're not potentially destroying data that's already in the database. We don't get any complaints. Okay? So here on slide 21, we have a statement that changes the default value. Alter table vendors, modify vendor name varchar 100 not null, default new vendor. Okay, well that's fine. Okay, but the next one will not work. Alter table vendors, modify vendor name varchar 10 not null, unique. The response from the system, error code 1265, data truncated from column vendor name at row 1. Okay, so that's saying, oh, hey, look, we're truncating data. We don't really want to do that. Okay. Here's the syntax for modifying the constraints of a table. So we can say alter table and identify the table. And we can say add primary key, or we can say add constraint name, foreign key, constraint definition. We can say drop primary key, or we can say drop foreign key. Okay, here on slide 23, we have a statement that adds a primary key constraint. Alter table vendors, add primary key of vendor ID. And here's one that adds the foreign key constraint. Alter table invoices, add constraint, invoices FK vendors, foreign key vendor ID, references vendors, vendor ID. Okay, so it's possible if we forgot to have a foreign key constraint that we can add it. Okay, if we add that foreign key constraint using the DDL and just type out the statement and we execute the statement, then it's going to run like that. If we should go into the graphical user interface part of Workbench and say, for instance, we want to add a foreign key and give it this same information, if you watch when you say you want to apply it, you're going to see that what gets sent to the server is the same thing that you would have coded by hand. Okay? Here's a statement that drops a primary key constraint. Alter table vendors, drop primary key. A statement that drops a foreign key constraint. Alter table invoices, drop foreign key invoices FK vendors. For the most part, you would be doing these things in the use case where you're just trying to get the design right. Okay? And you don't want to have to, drop the tables, start from the beginning, all that kind of stuff. We can rename a table. Rename table vendors to vendor. Oh, wow. He's finally seen the light. Here we are on chapter 11, and we finally are putting the table names into the singular. No. Okay, so we're able to rename a table. We can use the truncate statement to delete all the data from a table, but not the definition. Okay, so if we say truncate table vendor, the data gets wiped out, but not the definitions of the columns, not the constraints, not the indexes, all that kind of stuff. But the data is wiped out, but the definitions remain. A statement that deletes a table from the current database is to say drop table vendor. When we drop it, everything's gone. The data's gone, the definitions are gone. Okay? So what's the use case for these? Well, typically when you drop a table, you have changed your mind about the design. Or maybe you have a script that say drops your tables and recreates them when you want to create a fresh copy of your database, something like that. Truncating a table, this would be. I've had the use case where I've got kind of a temporary table, okay, where I keep a kind of temporary answers. And what I do is when I'm done using it, I truncate the data to release the space. And then later on, when I use it again, well, it's empty when I start. So here on slide 26, we're saying if we go to drop a table, okay, so here we're dropping a table in the EX, the example schema, the vendor table. And here's one where we're trying to drop table vendors. And when you go to drop a table, you're going to get the same kind of scrutiny on the relationships that it has to other tables that you would get that if you were doing a delete. Okay, so for instance, if we have a foreign key relationship between the invoices table and the vendors table, well then if we go to delete a row from the vendors table, if there are rows in the invoices table that point to it via foreign key, well, we're going to get an error. Well, the same thing happens when you go to blow away the whole table. Okay, if there's anything in the invoices table that is pointing to any row in the vendors table, well, you're not going to be able to drop the table. Okay, I mean, it's not going to allow you to delete the whole table any more than it would have allowed you to delete a particular row. So these foreign key constraints are going to maintain referential integrity even from things as heavy-handed as a drop table. As a result of that, there are times when you're trying to, say, drop tables and recreate them, you have to drop them in the proper order. Okay? So for instance, if we had that foreign key relationship between invoices and vendors, and we had a script that was going to drop them and recreate them, well, we would want to drop invoices before vendors because then when we went to drop vendors, we wouldn't have the problem of having rows in invoices that pointed to rows in vendors. Okay, so now we're going to talk about creating indexes. And I just want to remind you that in the product that we're using, MySQL, the indexes for primary keys and foreign keys are created automatically. So we never need to specifically create a primary key index or a foreign key index, having it created the foreign key constraint or the primary key constraint implies the creation of those indexes. Okay, so when we are talking about in MySQL of using a create index statement, it's some further index. Okay, so and why would we want to do it? Well, if we have a column that we use in a lot of where clauses in our selects, we might want to add an index to that column. Okay, and how would we do it? Well, the example in the middle here, we have a statement that creates an index based on a single column. Create index, invoices, invoice date, IX. That's the abbreviation that they're using. It's a pretty standard way to, a pretty standard suffix to give a constraint a constraint or an index name that says this is an index, IX. So we create it on invoices, invoice date. Okay, so again, you won't have to create any indexes except to the extent that we decide that we want additional indexes beyond primary key and foreign key indexes, which are created for us in MySQL automatically. This is the case where we're trying to speed up the queries because we think they're going to take too long without additional indexes. And the last example, a statement that creates an index based on two columns, create invoices, vendor ID invoice number index on invoices, and then in parens, vendor ID, comma, invoice number. Okay. A statement that creates a unique index. The primary key indexes are unique indexes because primary keys are implicitly have a unique constraint. The foreign key indexes, it's not true of. So we can have, it turns out that they don't have to be unique. But here, if we're keeping, if we're trying to create an index on a column that has a unique constraint, we can create a unique index. Okay, so we can say create unique index vendors vendor phone on vendor's vendor phone. A statement that creates an index that's sorted in descending order. That's example in the middle. Create index invoices, invoice total IX on invoices, invoice total descending. Why do we want that? Well, we might have a some selects that have a sort by invoice total descending. If we do, this kind of index could speed those up. And finally, the example at the bottom, a statement that drops an index, drop index, and then we have the name on vendors. So index name on table name. Now here is the SQL script that creates the AP database. Okay? And we've dealt with these. Okay? Now, when we run this script, and don't be surprised if you compare these slides to the code that you have, and it's not line for line the same. Could the code have changed since they generated these slides? Yeah, it could have. Okay. And also, when we create the 3 databases that come with the textbook, we have a sort of meta script that runs 3 individual scripts. What we have here is the individual script for the AP database. Okay? But the way it starts, drop database if exists AP, and then create the database AP. That works great. Okay. And then we say we want to use AP, and then we go to create the tables. Now, don't we have to drop the tables? No, you don't have to drop the tables, because implicitly when you drop a database, you've dropped everything inside of it. Okay, so all the tables, all the data, everything inside of the database is gone. Okay, so having begun by dropping the database, we don't have to worry about tables having stayed around from a former incarnation. And then we go to create the tables. So here we have the definition for general ledger accounts, and then terms. Terms. Then we've got one for vendors, including some table level constraints, right? And then we've got one for invoices, including some table level constraints. And this is, I think, a good example here on slide 31 that we can mix constraints like primary key, which in this case we defined at the column level. So we can have some column level constraints, and then we can also have some table level constraints. So we don't have the problem that we can only use one or the other at a time. Although we can't have column level constraints that conflict with table level constraints. So having already defined the invoice ID as the primary key, we can't come along later and then say that we want a constraint that's going to define the primary key. Well, no, we've already defined the primary key. All right. Then we've got here on slide 32, we create the table invoice line items. Okay, and you see that we don't really create any constraints at the column level. And that's because when we look down at the first table level constraint, we see the primary key is composed of more than one column, invoice ID and invoice sequence. Okay, so the way that you do that, you do not put a primary key on each of the column definitions. No, you leave it off, and then you create a multi-column primary key with a table level constraint. Okay, and then the very last thing we're doing here is we are creating an index called Invoices Invoice Date Index, IX, on invoices invoice date descending, why did we make it descending? Well, because that's the way we're going to sort it all the time. So we are, in a sense, pre-sorting by pre-sorting the index. Okay. Now here we've got at the beginning of some slides that show the functionality of MySQL Workbench, and I just want to point out that this is it's entirely possible that the layout of this screen might be a hair different than yours. Okay, don't worry about that. Okay, so here we're looking at the table information for the invoices table. This would be, to get this, you would go over on the left side in this navigator panel, hover over the invoices line, and then come out and click on the wrench icon to the right of it. That's how you would get what we're seeing here. Okay, so you can see all of the columns, you can see their data types, you can see a check if they're part of the primary key, you can see a check if they have a not null constraint. You can see a check if they have a unique constraint. So as you can see, we have a lot of not null constraints. We don't have a unique constraint for the primary key, but it's implicitly unique. That's the nature of being a primary key. So we don't have to add that constraint to it. The last of those checkboxes, AI auto increment, we have turned on auto increment for invoice ID. And then you can also see over on the right side there are some default values. Okay, now when you're using this kind of feature in Workbench, if you make some changes and they go down to the lower right and you click on apply, you're going to see the DDL generated for you to modify your definition of some part of that table. Okay, and if you modify a couple things, you'll see a script with several modifications. And if you tell it to go ahead and apply that, then it will send that to the server. So there's no magic in the way this Workbench actually works. This graphical capability that we see here simply takes what we asked for and turns it into the DDL part of SQL. And then when we confirm that we want it sent, it sends it to the server. Here we're on the indexes tab. Okay, so the first tab that we were on was down here. If you look in the bottom section, we were on the leftmost one, columns. Now we're on indexes. Okay, and we can see that we have a primary key index. Okay, we didn't have to ask for it. It was generated for us automatically. We have two foreign key indexes. Okay, we didn't have to ask for them. They were automatically created for us because we had foreign key constraints. In fact, they're named after our foreign key constraints. Okay, the last index, invoices invoice date, that's the one that we explicitly asked for. So of these four indexes associated with the table, only one was explicitly defined in our DDL. The other three were implicit in the DDL when we identified foreign keys and primary key. Okay. Now we've gone to the next tab over to the right. Look down here along the bottom. We're on foreign keys. and we can see the foreign keys that came from our constraint. And so we have the foreign key name, we have the reference table, okay? And then when we come over to the right, when we highlight a line, we can come over to the right, and we can see that this invoices FK terms is relating it from our terms ID to their terms ID, column, reference column. You can see that. Okay. Okay, so the foreign key options are currently set to on update or on delete restrict, which means we're not going to get any of that on delete cascade behavior if you want to fool with these options. But you're going to get fancier behavior. But the default is to maintain referential integrity on updates and deletes. Okay? And again, if you change things here in this view and you click on apply down on the right, nothing magical happens. It gens up a bunch of alter table statements and it shows them to you. And if you approve them, they're sent to the server. So there's really no magic in how this actually, well, I guess there is kind of magic because it gens them up for you, and that I think is very handy. Okay. But it's all done with the DDL portion of SQL. Okay, now before we're done, we've got to talk about some of the more I'd say mechanical parts of database design and table design. One of the things is we have to pick a character set. And two commonly used character sets are Latin 1, which has most of the glyphs in it that are used in US and European languages, and UTF-8, which has all of them plus many, many more. It has come to become the default in MySQL to use UTF-8, and that's really become the default in a lot of technologies. Okay, these Unicode character sets like UTF-8 are the way that we're going. Okay, we have more internationalized applications, so that's what you're going to see. And the default when we installed our product was UTF-8. Okay. Now, in addition to picking a character set for our database or for our table, we can also pick a collation rule. Okay. So we have Swedish with that's case insensitive, that's CI, general case insensitive, general case sensitive, and binary. Okay. What happens is that we typically get the general collation and case insensitive. Okay, and that generally works for us pretty well. Okay, now since the default character set that we've been getting is UTF-8, well, we don't get these collations. Okay, these are all for Latin 1. But if we look on the next slide, we can see that we have a parallel set of collations for UTF-8. Okay, so we've got UTF-8 general case insensitive, UTF-8 Unicode case insensitive, UTF-8 Spanish case insensitive, UTF-8 binary. And I'm looking at what I got on my implementation. And it looks like what we're getting, the way we installed this thing, is UTF-8 general case insensitive. And that seems to be doing the job for our English language uh, uh, usage right now. If we had some fancier requirements, well, then we might have to do something fancier. Okay? But not right now. Collation names, if the end names with, if the collation name ends with CI, it means it's case insensitive. If the name ends with CS, it means it's case sensitive. If it ends with bin, it means it's binary. Okay? And again, we're the one that we've been using for the whole course is case insensitive. It seems to have been serving us fairly well. How do you view all the available character sets for a server? Well, we can say show char set. Okay, so when I do that for my server here and run it, I get a lot more than I thought I would get. So I get uh, Big 5, Deck 8, CP 850, a whole bunch, Latin 1, Latin 2, ASCII, goes on and on and on and on and on. Okay. Included is UTF-8. So all of these, so there are lots of possibilities for character encoding. Okay. And I can also say show char set like, and let me just say like, and I'll say UTF-8. So I want one that starts with UTF-8, and let me run that. And I didn't put a closing apostrophe there. Let's try that again. And I just get UTF-8. So the char set UTF-8 is UTF-8 Unicode, and the collation is UTF-8 General CI. Okay, so that seems to be what we're using right now, at least the way I've installed the product. How to view all available collations for a server? Well, we could just say show collation. So let me try that while we're here. Show collation. Run that. And I got a whole bunch of those. Got 222 rows returned. So seems like even if you had a pretty unique set of requirements, you would be able to find a collation in MySQL that would get the job done. How to view the default character set for a server? Okay, well, let's look. Ours, I believe, is UTF-8. So let's say show variables like character underscore set underscore server. Okay. It doesn't like that. Oh, it doesn't like it when you don't have the right closing apostrophe. Character set server is, as I said, UTF-8. Okay, and show variables like collation server. It's going to give us the collation that I said we're using. Two L's in collation. I just want you to remember that. So it says we're using UTF General CI. That's not surprising because that's what it was when I looked it up. How do you view the default character set for the database that you're currently using? Um, so character set database. So let's try that. That's wild. Well, I've got to say I had a runaway keystroke here. Sometimes when I'm using my virtual machine, I'll get a runaway keystroke in the virtual machine. Um, Not fun. So, character set database. Character set database. All right, that was a little better behaved. UTF-8. And the collation database is the same one that we had before. UTF-8 general CI. Okay, so I just want to point out that these, the character set UTF-8 and the collation UTF-8 general CI is what we've been using for all the databases in this course so far, and they've been working great. Okay, so not bad. So, how to view the character set and collation for all the tables in a database? Well, we can use this a table called information schema. I'm sorry, we can use the we can use this. So let me just come on, baby. Let me copy this and throw this out. So this is a way to make this happen. And when I do that, I see that the table collations are all UTF General CI. Okay? Because that serves us well. Okay? So what we really did is we did a query of one of the tables in the schema that holds system control information for MySQL, and this is a built-in database or schema called information schema. Okay. All right, that's where we were. Okay, so we do some practicing in the exercises on setting these char sets and collations, okay? Just so you'll know how to do it. So for a new database, okay, we could say create a database and then give the name char set name, collate name, okay? If we don't say what the char set and the collation sequence will be, well, then we're going to get the defaults for our installation, which is what we've been getting all along. Here's a way to change an existing database. So we say alter database AR char set UTF-8 collate UTF-8 general CI, and it will convert it and change it. If we just want to change the char set, we can do that. If we just want to change the collation, we can do that. you can set the character set and the collation at a table level, and that might be a thing that would make sense based upon the kind of data that was in the table. Um, I don't know. Maybe you have a table that has foreign language book names or something like that, and you want to get um, you want to get a collating sequence, a sorting sequence that, for instance, in this case, would take uh, Swedish alphabetization into account. Well, you could do that. Okay. You can also do it at the column level. Okay. So here we're declaring an emp name column, and we are setting the char set and the collation sequence at the column level. Okay. We can even do it to an existing table and get a conversion. Okay. Now, there are more than one storage engine for MySQL. And the two that we are interested in are called InnoDB and MyISAM. And the newer of the two is InnoDB. And all of the table, and that's the default for the installation that we have. So all the tables that we've been getting so far are InnoDB tables. That's been working just great. So how do we view all the storage engines for a server? Well, we could just say show engines. Okay, so let me see if I do that on our installation. Show engines. 9 rows returned. So I've got InnoDB, MRG MyISAM, memory, black hole, MyISAM, CSV, archive, performance schema, and federated. Okay? So those are all the possible schemas. What's the one that we're using? Well, we're using InnoDB is the default. Okay. If you want to see what the storage engine for all the tables in the database is, you can go back to this information schema and look at the tables table and look at the table schema column for the AP database, and you'll see that all of the tables are implemented with the InnoDB engine, which is the default for the way we set the database up, and that's working just fine. So we can specify the storage engine. So we can say engine equals engine name. So where could we do it? Well, we could do it for a table. Okay, so we create table product descriptions. Okay, then we have the column descriptions, and then outside of that we say engine equals MyISAM. Okay, and then we're saying alter table product descriptions engine equals InnoDB. Okay. You could set the default storage engine for just a current session. We can say set session storage engine InnoDB. Okay. Not something that I want to recommend to you because things are going pretty well using the default, which is InnoDB, and for the most part we don't want to muck around with it apart from the practicing that we may do in the exercises just to demonstrate that some of these things can be done. So that's it for the lecture. Um, there will be a tutorial demo in which I think I'm going to do a few of the exercises from the book. Okay, not the ones from my guitar shop. So that will be forthcoming. In the meantime, I'm going to say bye for now.